Hi, students. It is Saturday, January 14th. This is a preview for week 3. So just a little recap of what's been going on. So far, pretty good job on all of you with your group meetings and getting those recorded. I haven't watched all of them. I haven't watched any of them. I've watched little snippets of a few of them, but I'm looking at them. Seems like you're getting the hang of it, so I appreciate that. Also, I appreciate that you posted those group meetings on the appropriate discussion board for that lesson. Starting this week with lesson 4, the participation in your group meeting is a graded assignment, and it is worth 10 points. And I believe it goes in the, same part of the grade book as the group quizzes go. Let's see. Oh, it's great that when you post the link that you're also telling me the names, not of the people that are in your group, but I need to know the names of the people that actually attended that group meeting. If others in the group want to post a follow-up, says thanks. It used to be with iLearn 2.0, it used to be that was the only way to trigger that a graded assignment needed to be graded, but iLearn 3 is not that way. So you don't have to do that. If you want to do that, that's fine. But you don't have to do that. Just whoever's posting the link to the entire group meeting can just say, here's our link. Here are the people that attended, and things went great, or we have problems with this, or whatever. So if in the instance that you forget or neglect or don't know how or whatever to start recording your meeting, don't sweat it. What's important to me is that you're actually meeting. The recording is a nice to have after the fact, because if we need to go back and review it, or if you want to go look at it again, it's there. But don't ever find yourself thinking, oh no, forgot to record the meeting, we're not going to get credit for it. That's not the case. You will get credit for it. I would like you to, if you don't know how to, I'd like you to figure it out and ask around and see how it can be done. But there's no reason to redo your meeting or anything like that. Had a couple people ask me if it's okay to have both group meetings at the same time during the week. It's not ideal, but if that's the way your schedule works out for you, that's good. If you're given a short shrift by just having a 45-minute meeting for 2 lessons, probably not really meeting the spirit of what we're trying to do here. But that is the flexible part of this class, so I'll let you guys decide and choose. And the reason it's not a great idea is because it's awful hard to prepare for 2 lesson meetings and then have it just for 1 group meeting. Anyway, also I'll send out an email about this, but we actually have 3 students this semester in Ghana. Love having students from Ghana in this class. However, they face 2 really big hurdles as they're taking this class. Number 1 is some of them, not all of them, but some of them sometimes have very unreliable internet, Wi-Fi access, internet access, and quite often they end up going to a public building or their local church house to participate in group meetings or send emails or just to do anything. So that presents a little bit of a challenge. It's not nearly as convenient as for most of us. We just do it in our home or in our place of work or the library or Starbucks or whatever. Second challenge is they're 7 hours ahead of Mountain Time. So in order to meet with a group, it can be very, very difficult. So anyway, one of those 3 students, I think the other 2 so far, I'm pretty sure they're in groups, but I'm not exactly sure. But one of the students, her name is Benedicta Gabbiano. I don't know if I'm pronouncing that correctly or not. But she's struggling to find a group. She really would like to participate with somebody. Now, if I remember correctly, she told me her availability is like 4 a.m. to 6 a.m. her time, or 5 p.m. to 7 p.m. her time. I don't think the 5 p.m. to 7 p.m. is really going to work out. I don't think any of you guys are meeting after midnight. And if you do, why? Anyway, so let's see, 4 a.m. to 6 a.m. is for Mountain Time. I guess that's 11 a.m. till 1 p.m. If you have a group and you are typically meeting around that time, and even if it makes it a group of 5, I'm okay with that. But if you would be willing to show some compassion and say, yeah, we'd love to have Benedicta in our group, that would be great. If you will let me know. Like I said, I'll send out an email about this too. But she would really love to be able to spend some time with people discussing the topics in class. Okay, So speaking of topics in class, a couple things that are going to happen this week. Lesson 4 is, before I get to that, SPSS. I've gotten a few notes from some of you that say, hey, I'm having some struggles with SPSS. I'm not hearing much from most of you. I think most of you are getting it. If you're not getting it, please, 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 you have to get it. And you have to become familiar with it. Let me tell you what's going to happen if you don't. We are going to come to a test. First test is, okay, this coming week is week 3. The first test is week 5. It's only 2.5 weeks away. There will be questions on the test that require SPSS. And the way they require SPSS is that the file that will be provided to you, the data file, will be a .save file. It will not be it'll be .sav, .save. That's the extension that's used for an SPSS data file. It will not be a .xlsx file, so you can pull it open in Excel. So if you don't have SPSS on your PC, or you don't know how to use it, or you haven't been using it, and you've just been trying to kind of skate by without getting involved with SPSS, you're going to come to the test, and there are going to be some questions that you can't answer, or I'm going to get some panicked texts saying, hey, I can't open this data file, and my first question is going to be, have you been using SPSS? Well, no, I kind of haven't really gotten around to it. I'm sorry, you're going to have to miss those questions on the test because they require SPSS, and that's just how it is. It's not my favorite thing, and frankly, if you would have taken this class next year at this time rather than this year at this time, probably SPSS is going away for various reasons. But it is how it is right now, so we have to stick with it. I have a commitment to do that for the school. Okay, so get that up and running. If you're having trouble with it, please, please, please give me a call. I probably won't be able to help you, but I will be able to give you encouragement and say hang in there. If you're having difficulty, if you're having technical difficulties, contact tech support on campus. All right, difficult concepts coming up this week. Lesson 4 is about discrete probabilities, discrete variables. So what is a discrete variable? Well, a discrete variable is when a continuous variable is like when you're measuring something. So if you give 1,000 different people a ruler and go say, hey, go measure the length of that table, you theoretically could get 1,000 different answers and they would be a continuum. Discrete, on the other hand, is how many kids do you have? Well, you have 1, or you have 0, or you have 1, or you have 2, or you have 3, or you have a whole bunch. But you can't have 2.73 kids. You can't have negative 1.82 kids. So generally discrete variables, and this isn't strict, but this is good enough for this class. We treat them as though they are whole numbers with big spaces in between. From 1 to 2, there's a lot of stuff in between 1 and 2. Quite often categorical variables can also be considered as discrete, because if you say, hey, what's your favorite color? Is it red or blue or green or brown? Well, you could code those also. Red could be equal to 1, blue could equal to 2, green could be 3, brown could be 4. Your favorite color can't be 1.4, okay? Anyway, so those are discrete variables. There are some probabilities. There are 3 probability rules associated with discrete variables. Well, they're actually associated with all probabilities. Probability must be between 0 and 1. Can't be negative, can't be greater than 1. If you have a quiz or a test and the question says, hey, what's the probability of event X happening? And the answer you come up with is 2.7, it's wrong, okay? It needs to be between 0 and 1. Furthermore, the sum of all possible outcomes for a probability is equal to 1. For instance, if you have an 8-sided die, if you play different games, sometimes you'll have 8-sided die. What is the probability of rolling a 1 plus the probability of rolling a 2 plus the probability of rolling a 3, ... all the way through the probability of rolling an 8? Well, that's every possible outcome, so the total probabilities of all that stuff is equal to 1. And the third rule of probability is probably the most important one. And it is realize that the probability of event X happening is equal to 1 minus the probability of event X happening. I'm sorry, let me say that again. The probability of event X not happening is equal to 1 minus the probability of event X happening. Okay, so what are the chances I'm going to have 3 people show up at my door tonight? Well, it's about 12%, let's say. So what are the chances I'm not going to have 3 people show up at my door tonight? Well, it'd be 1 minus 12%, or 1 minus 0.12, so 88%. So the probability of having exactly 3 people show up at my door tonight is 12%. The probability of anything other than exactly 3 people showing up at my door tonight would be 88%. Those are the 3 rules of probability. Make sure you understand them and how they work with each other. Lesson 5, I'm going to start talking about the standard normal. We're going to start talking about the normal distribution. And then every now and then we're going to say this thing called standard normal distribution. Okay, there's a huge difference between those two, and I want you to pay close attention to the language. A normally distributed variable, a normal distribution, has a mean and it has a standard deviation. And those can be pretty much anything you want them to be, other than standard deviation can't be a negative number. But, you know, I can have a mean of 70 and a standard deviation of 10. I can have a mean of 400 and a standard deviation of 35. I can have whatever. And you know the distribution it's hump shaped. However, there's this special normal distribution, and it is called the standard normal distribution. And it's almost always capitalized the whole way too. The standard normal distribution is a very special normal distribution. It's still normally distributed, but it's very special in that the mean is 0 and the standard deviation is 1. So whenever anybody says the words standard normal distribution as opposed to just normal distribution, they're talking about that specific distribution. So make sure that you understand that. We're also going to have this thing called the 68, 95, 99.7 rule. I'm not going to explain it right now. It's an approximation. It is not exact. But whenever a question mentions the 68, 95, 99.7 rule, it wants you to apply the approximation and not the exactness. So basically in lesson 5, we're going to learn how to calculate exact probabilities, and then we're going to also learn how to approximate probabilities. Make sure you know which you're doing and when. Okay, there's a normal distribution applet. Let me show you what that looks like. If I can share here real quick. Where's my share button? Right there. Okay, let me pull this open. You will have a link to this in your in lesson 5, I believe it is. This is the normal probability applet. This is a great tool for figuring out what probabilities are. Now, again, this is cart before the horse just a little bit, but you'll get to it in lesson 5. The area under this entire curve, so I'm showing from -4 to 4, but this really goes on from -infinity to infinity. The area underneath this entire curve is set to be equal to 1. So when I'm doing a probability, what I'm going to do, you can click on these 3 regions, turn them blue or white. So if they're white, they're deselected. If they're blue, they're selected. So what if I calculate a z-score and it's 2.2, and I want to know what the probability of having a value greater than that z-score is? The way to do that is to go to the right and put 2.2. Now, before I hit enter, I want you to notice something. This one on the left says -1. But when I hit enter, watch what happens. Okay, it treats them as symmetric, and it says, oh, you've got a z-score at 2.2. By the way, there's another z-score over here at -2.2 that we also think you ought to pay attention to also. Okay, now the question was, what is the probability of calculating a z-score or having a z-score higher than 2.2? Higher means greater than, so this area to the right of 2.2 is greater than. If I click on that, select it, and turn it blue, the area over there is 0.0139, or 1.3%, if I wanted to express that as an area, as a percentage. So if I wanted to say, hey, what is the probability of having a z-score greater than -2.2? Well, I would still set my -2.2 here, 2.2 over here, but then I would go ahead and highlight both the center part and the right tail, because I want to be greater than -2.2. This is the red line that represents -2.2 over here. And all this stuff greater than is all that junk right there. Okay, that turns out to be 0.9861. So these z-scores, because the normal distribution is symmetric, these z-scores will always be symmetric. So let's suppose I did this at 1.3, and I just wanted the stuff above 1.3. You'll notice that's 0.0968. Well, if I do the stuff that's less than -1.3, that also is 0.0968. And if I add up all 3, if I select all 3 regions, it should always say 1. So that's the area under the entire curve. Okay, I know that this is just a little teaser and you really don't know how to use this or why to use it yet, but you will get there. Okay, let me stop sharing now, and I think I've got one other thing to tell you. Let me find it. Okay, so we're also going to be calculating a z-score in lesson 5. This is a z-score for an individual value. Later, we're going to do z-scores for sample means, but we're not doing that yet. Right now, we're doing z-scores for an individual value. So what exactly does a z-score mean? Well, the calculation of the z-score looks like this. If you have a distribution and it has a known mean and it has a known standard deviation. Okay, so this is a normal distribution. Make sure I can see this here so many of you guys can see it. Okay, so mu is my mean and sigma is my standard deviation. That's what this little symbol is here. This is sigma. Mu, it's spelled mu and it's pronounced mu, like a baby kitty cat. Okay, so if I wanted to calculate a z-score, I am going to say my z-score is equal to my value, which is x, minus mu, which is the population mean, divided by sigma, which is the population standard deviation. So if you think about this, what is the z-score? Well, it's telling me how many standard deviations away from the mean am I. For example, and we'll just do one that's kind of easy to do in your head. Let's say mu is 50 and x is 70 and sigma is 10. So it's 70 minus 50, that's 20, divided by 10, that's 2. So my z-score for 70 is going to be 2, assuming that mu is 50 and sigma is 10. What does that mean? That means I'm 2 standard deviations. Standard deviation is 10, so 2 standard deviations would be 20. I'm 2 standard deviations above or higher or greater than the mean. So 70 minus 50 over 10 is 2. That would be my z-score. Same scenario, same mu, same sigma, but x this time is negative 30, or I'm sorry, it's 35, let's say. So 35 is 15 less than mu. So that's 1.5 standard deviations. And since it's less than, it's going to be negative. 35 minus 50 would be negative 15 over 10 would be negative 1.5. So 35 is 1.5 standard deviations below or less than mu. All right, so z-score is going to become your best friend. I'm going to send you the links to 2 mini lessons. We don't do a ton of calculation in this class, but we do a few calculations and we do them over and over and over again. So I'm going to send you 2 mini lessons this week. One is for how to calculate a percentile. That's something that causes a lot of problems. So look at the mini lesson 2. That. The other one is how to use Excel as a calculator. Now, if you're real slick with Excel and you know how to use formulas and all this stuff, this should be very second nature and very easy for you. If you have no idea what I'm talking about there, I want you to really pay close attention to that mini lesson because it can really give you a lot of help in determining how to not have to be punching stuff into a calculator all the time. If you got to do the same calculation over and over and over and over and over again, this is really a slick thing to do. Okay, I got to run, so I'm going to stop this now. Have a great week. Give me a call or a text or an email. Let me know how things are going, and we'll talk to you soon. Thanks. Bye.